Good morning, class. Welcome to another lesson on measurement. So for today, we're going to be focusing on a new area, and as you can see here in our learning objectives, we're continuing with the same learning objectives of understanding how to measure time, temperature, length, area, volume, mass, and density. But we've already covered length, that's why I've got it crossed off here. Today, we're going to be focusing on area and volume, okay? And I'll talk about those in a minute, and then we're going to continue with the same learning objective of understanding the different instruments and tools we use to take these measurements. I'll cover a few more today, but just a similar thing. So with area, it's very similar to length, and we'll see that in a minute here. So after you've taken your measurements, right, you've used whatever tools you needed to take your distance measurements, right? So to measure distance, we use things like a ruler or a tape measure, or even a trundle wheel, the thing with the big wheel on it and the stick coming out of it. We use those to take our measurements, right? And that's measured in meters. And you can use those to find something's area. And this might sound a lot like maths class, but bear with me here, and you'll see why we need them in science. But for example, in everyday life, you might need this to see maybe how a rug fits in your room, right? You need to see how much space it takes up. Like a two-dimensional space, because its area is flat, right? Or maybe on a farm, you need a certain amount of area for each animal. So as you can see here, this is kind of what we're talking about when it comes to area, right? You have something's width and you have something's length. You multiply those two together, and that gives you something's area, okay? And why is all of this important? Why is any measurement important, right? And I found a cool little story here, something about a Mars orbiter, something that was going to go off to Mars, and you can read this in your own time. But basically, it was a satellite they were sending to Mars to measure its climate, and something went wrong. They used the wrong measurements, and they lost the probe, and it cost them, as you can see here, $125 million because they screwed up a simple measurement. So even if you feel like this is something you might already know, or you just think it's maybe not important, just realize that even way high up in NASA and all these really what you think might be really important areas, sometimes they make these little small screw ups when it comes to just measurements in general. So you guys really kind of need to know this and get this patted down, because even a small screw up can cause somebody $125 million. Okay, area and volume. The next few slides we're going to cover are how to find the area of an object and a volume of an object. So as you can see here again, area is more of this two-dimensional kind of, if you imagine a rug, I think is a perfect example. You lay it on the ground, that's how much space it takes up on the floor, right? Whereas volume is three-dimensional space, right? It's 3D. So if you wanted to see maybe how much room a bed takes up in the entirety of the room, right? So not only how much floor space does it take up, is it too tall? Wardrobe, same thing. Does it fit through the door? Does it fit in is the height of the room? Stuff like that, okay? So volume is three-dimensional, area is going to be two-dimensional. So measuring the area of a rectangle, okay? So we have that same diagram. Anywhere you see the red, make sure you're copying that down into your copies, okay? So to measure the area of a square or a rectangle, you multiply the length, which is always given. So the length is this 8.75 centimeters by the width, okay? And for example, so if we were to calculate this, so you have your formula here, area equals length multiplied by the width. Use your calculator for this. So we just take the numbers that are given here. So the length is 8.75 centimeters multiplied by the width, which is 5.2 centimeters, and that gives us 45.5 centimeters. Now see this here, it says squared, right? So however many centimeters you're multiplying it by, so if this was volume, you'd be a different formula. You'd have 3 centimeters you have to multiply by. It'd be a 3. But every time you calculate area, remember we always have to have units, always have to have something here. If you just had, this wasn't here, you just had 45.5, just the number, that doesn't mean anything. In science, we always need units. So we have our centimeters that we were given, and then since we multiplied 2 centimeters together, that's squared. Okay? Area is always in meters, centimeters, millimeters, squared. Okay? So Just a quick add-on, measuring the area of a triangle if you needed to. The area of a triangle on the right is calculated by this on the top. Area is 1/2 times the base, which is the bottom of the triangle, multiplied by this height here, okay? So this is just a quick working that out. So if the base is 7.5 centimeters, multiplied by the height, and then multiply that by 1/2, it gives you this. This isn't as important right now, but it's just something that you guys need to know, okay? So that's area. You guys will have to do Google Forms, and I'll give you plenty of examples and practice problems to be working on this. This should be padded down. Make sure you're using a calculator for this and getting the right answer. Take your time with them, okay? Give you plenty of examples and practice problems until you guys can get this right. So volume then is adding that third dimension. Volume is very important in science. Imagine when you're mixing different chemicals and you need very precise and accurate measurements of those chemicals. You need to, and a lot of the times those chemicals are going to be in liquid form, so you need to be able to measure the volume there. And for example, even in everyday life, again, I won't read this whole, it's another story here, but when people refuel planes, they need to understand how volume relates to weight and all that other stuff. And if they get it wrong, basically you might not have enough fuel, the plane might go down. That's what happened here. It was similar to the previous story of the Mars probe, where they converted wrong, and instead of having the amount of pounds of fuel, they had kilograms, and they didn't have enough, and then the plane went down. So just an everyday example of how volume is very important, even in something as important as a plane. You know, you don't want those going down. So the volume of an object, make sure you have this taken down, is how much space it takes up, 3D space. So if you have maybe, like I said, a wardrobe or a dresser or even a table, you need to see how much space it's going to take up in the entirety of the room. You use volume. Or you want to measure how much a cup holds. If you're baking, right, you need to know how much milk you need for your cake. That's volume, how much space it's taking up there. And the SI unit for volume is a cubic meter, okay? Not liters, cubic meter. So whenever you see this 3 in the upper right-hand corner of something, that means cubic. So we use the following formula to measure just regular cuboids, so just regular, anything that looks like a kind of a cube, like this. This is the formula you can use, so it's length times width times height. Notice it's very similar to area, length times width. You're just adding in a third dimension, right? You're adding in the height. Width, length, and then you're adding in the height. So say the length of this cube over here on the right is 20 meters. The width going back is 10 meters, and the height is 8 meters. You just stick those into the formula above, 20 times 10 times 8. Stick it into your calculator. It gives you 1,600 meters, and then again, cubed, right? We have 3 meters, 1, 2, 3. That means that our unit then, always have to have a unit, needs to be meters cubed. If this was only area and we didn't have the 8 here, it'd be 20 times 10. We'd be solving for the area of the bottom of it there. It'd be 20 times 10. That would be, the unit then would be meters squared with a little 2, okay? All right. So volumes of fluids are usually measured in liters. This is where this comes in. This is just really quick. We know by conversions, that's the units we were talking about in the last video. 1 liter equals 1,000 milliliters. This is how we get from cubic meters to liters then. 1 cubic centimeter equals 1 milliliter. So then if we want to measure in liters, we know that 1,000, because 1,000 milliliters we know is 1 liter. If 1 milliliter equals 1 centimeter, then we know that 1 liter equals 1,000 cubic centimeters, okay? All right, so some instruments to measure volume. You need to make sure you know each one of these, so what you need to do is take each of their names down and maybe draw a quick little diagram of each. You've used the graduated cylinders. I think we've used the graduated pipettes. Burettes are, you'll probably use those maybe in leave insert and volumetric flask, again, probably closer to leave insert. These are the different tools that or instruments that we use to measure volume. This can come up on the junior cert. They might show you a picture of a graduated cylinder, say, what is this and what does it measure? You have to be able to say it's a graduated cylinder and it measures volume. Okay? So when we're reading these, this is very important. So I know there's a lot going on here. I'm just going to skip down through. We talked about parallax error in the last video. Basically, whenever you're taking any measurement of any kind, whether it's volume, you're measuring the volume of a graduated cylinder, or you're taking the measurement with a ruler and trying to measure the length of a piece of paper, you need to be looking straight on. Don't be looking on the top, don't be looking at the bottom, straight on, to avoid this thing called parallax error, which can mess up your measurements, okay? Also, this is not, I think this is even more important, when you are measuring with a graduated cylinder, you might see something like this. Notice how this kind of dips down below. This is called the meniscus, right? And what you do when you're measuring with a graduated cylinder, you always measure from the bottom of the meniscus, okay? Not from the top. Notice how there's a big difference there. So if this is 30, this long line here is 30, this is 31 here, this next line is going to be 32. If you're going to measure from the top of the meniscus, which is, notice there's not much actual liquid above the meniscus, it's just these little parts right here, you're going to get all the way up to 33. But if you measure from the bottom, it's going to give you a much more accurate measurement at 32. Always measure from the bottom, okay? So maybe you need to measure an irregular object. So for some reason you walked out into your garden and you're like, I really want to know what the volume of this stone is, okay? And you can't really, obviously it's a solid, so you can't just stick it into a graduated cylinder and say it's this much volume, right? It's either too big or, you know, it's irregular, right? There's going to be a lot of empty space around it, and that's going to mess up your measurement, right? So what you can do is you can take that stone and you can stick it into a graduated cylinder that already has water in it, right? So you fill up the graduated cylinder, you fill it up to what here is 6 milliliters, right? We're measuring in milliliters. Fill it up to 6 milliliters. You then stick that stone in there and see how much the water rises, because that then is telling you how much space it takes up, okay? How much water is it displacing? Once you stick that stone in there, you measure, so if it was at that's 6 milliliters there, it goes up from 6 to 1 to, it goes up to 7, or it goes up to 8, right? From 6 to 8. That's a rise of 2 milliliters, or we know that milliliters are also the same as cubic centimeters. That tells us that the stone then is 2 cubic centimeters. Okay? Just as easy as that. It doesn't matter what it is, as long as it fits in the graduated cylinder and it doesn't overflow the water, right? Stick it in there, however far it rises, that's how much the volume of that corresponding object, okay? Another way we can do this, and this is something that's a little bit more difficult to show, is something using called a Eureka can, okay? And I'll show you guys a short little video here. So if you look over here, and it's kind of hard to hear, so I'm just going to kind of talk over it.
Guys, today I want to demonstrate how you find the volume.
So if you look at this, it's kind of just a little can, and it has water in it, and he's filled it all the way up to the brim there, right up to where the spout is right here.
Non-uniform objects.
And he has this mass.
It's approximately a cylinder. But let's say you want to find out what the volume of this object is. So one method you can use is the Eureka can. Now a Eureka can is filled with water, and it's got this little lip here. So as I put the object inside, the water is going to come out. What I can use is I can use a measuring cylinder to capture the water. Now, the volume of the water that gets displaced is going to be equal to the volume.
So notice as he's putting this object into the can, there's water coming out of the spigot here, right? Because it's filled up all the way. If you look back at our diagram here, this was filled up all the way to the brim, and once he sticks that stone in, the water goes up because it's displacing all that water, and it starts to pour out that spout, and he's catching it with the graduated cylinder. So if look back at this video.
let this collect that with water.
I'm going to skip near the end. Notice that there's,
Drops, but roughly,
notice now there's water left in the graduated cylinder there, okay? And that is exactly how much space that that mass object he dropped into there takes up, okay? So that's using an overflow or a eureka can, whichever one. It has two names, okay? Okay, so that's today. Pretty easy, just explaining area and volume. So what's going to happen now is you're going to find there's a Google Forms quiz as a review of last week's work. So it's kind of talking about just a few questions on how to take measurements of distance, and then also today's work. And then also you guys need to upload a picture of the red words, making sure that you copy those down into your copy. Okay? All right. Thanks so much, guys, and I will talk to you on Wednesday when we will have our next live class. Thank you.